Hi everyone. I continue on the lesson. So now we are moving to topic 11. Topic 11 is application of percent, and so let me see if I can move. Just zoom in. Okay, so application of percent. So we will see different definition of percentage, and we start from percent change, percent error, percent yield, and just concentration and those things. So for many of them you heard before. Okay, so you know about them. So just to refresh your mind, when I start with just before I start, I like to talk about percent. So we know percent is just the same as fraction, like part over total, part over whole, but whole or total here is 100. So it's either 100 or I consider 100. So for example, I say 30% in my class, they, for example, didn't attend in office hours. This doesn't mean I have 100 students and 30 of them didn't come. No, this means I consider my class, how many they are, I just consider the total number 100. And then I can make a proportion and find the answer. And these are all from before that we did. That just three types of proportion for parts or total or percentage, which I emphasize even in the report for the week that you did. I emphasize that you had to have example and definition on them because you need them here. Okay, so if I say, for example, 30%, so this percentage goes here and 100 goes here. I can have 100 up and also percentage down, but it doesn't look good, and so that's just agreement between us that we always use percentage up and 100 down. And then the other side, part over total. So it's always part over total because I have percentage over 100. Okay, so for example, I can say 15 of my students, for example, 15 of my students over 60, for example. Okay, so then I can say how many over 100. Okay, and then you can find the answer, right? So you can say, okay, what is the percentage here? So here the percentage is, that's 25%. Yes, makes sense because it's a quarter. A quarter of 60 is 15. Okay, so and a quarter of 100 is 25%. Okay, so we knew this before and we did many questions. I ask for part, I ask for total, I can ask for the percentage, and you can tell me what is the answer. Okay, so now I want to talk about percent change. Percent change. So as you hear, percent and change. So here a change is involved. So I have an old value, I have a new value, and of course I have a change because I have new value minus old value. Okay, that's a change. Yes, but what's the reason I say percent change? Okay, so maybe I can give you an example. For example, if I have something for $100 and then I say, okay, the next week, for example, the price is going to be $150. Okay, so let's say I have something else for $1,000 and I say, okay, the next time I go to buy these things, for example, this thing, it's $1,050. Both of them changed $50, but it's not the same because one of them went from 100 to 150, which is 50% change. One of them went from 1,000 to 1,050, which is just 5% change. So it's important that I compare change with the original amount to see this change is what portion on what is this change compared to the original amount. Okay, so when I give you this example, you can keep this in your mind and then you don't forget that the formula is this, because many times I see a student, they forget here they have to use original value in the denominator or new value. Of course original value, because I am comparing the change with the original value. Original value is what I have and change is the new thing. Okay, so I find the change, which is new value minus original value. I use the top, which is 50 for my example, and then original value will be in the denominator. and then I am comparing. Okay, so in some books you see for the top value, so they use absolute value, so just absolute value. Here we don't use absolute value, and it doesn't matter. It just means the percent change just means increase or decrease. Okay, so if I have, for example, if I have new value minus old value positive, yes, of course it is so just increase, and for the other case it's decrease. That's it. Okay, but percent change, when I talk about percent change, I have to just think of the positive part. Okay, so how about this example here? If something changes from $100 to $150 or $1,000 to $1,050, so maybe I can add dollar sign here, so it doesn't matter. Okay, so here I can find the percent change. Percent change for one of them is 50%, which is a very high amount, so you really don't expect the prices just go up like that. And so the other one is just 5% change, although both of the change is just $50. Okay, so I want to compare with my original value to see what is the change compared to original value. Okay, so now let's do some examples. Find the percent change when a quality changes from this to this. Okay, so from 29. So remember, from this means old value. So yeah, old value. And here is new value. Okay, so x over 100 equal 57.6 minus 29.3 divided by 29.3. Okay, so then it is x over 100 equal 28.3 over 29.3. Okay, and I can find x equal 96.58, and because here I have, of course here somebody has to tell me these are approximate. I can consider so 3 significant digit, but I have to know. Okay, here I don't know because it's just a quantity changes. I don't know what is a quantity. Okay, so I just consider. Okay, so that, and then I underline, and then I do this, and then this is 96.6%. This is the percent change, and it's a very high percent, because if even you look, so it's 30, almost 30 to almost 60. It's very high, so almost double. Okay, so that's why. So here, so that's 96.6%. So how about here? The temperature in a building fell from this, see, fell means going down. Okay, so from this to that. Okay, so this is old value. Crazy. Old value, this is new value. Okay, so it's 19 minus 21 divided by 21, x over 100. And x is x over 100 is minus 2 over 21, and x is minus 9.5223. Okay, so here I can do just this, it is almost minus 9.52%. Okay, so I can say the percent change is 9.52%, and negative shows that it decreases. I had decrease. Okay, so that's the thing. When I talk about these numbers, so I consider just to have sentences, you have to have explanation sentences, conclusion sentence. I can have that. Okay, so here don't forget. So here a student earning, this is a very good question. A student earning from, so it is just the student have, like, the student has $425 per week. Okay, so they are working for SSF office, so it's just an on-campus job, which is so good. Okay, so, and they receive 14% increase in pay. What is their new pay? What is the new salary? Okay, so here what I'm looking for. So I read the question, I understand I'm looking for new value. I'm not looking for percent change. I have percent change. Okay, so here I can say, I can find the formula here. Okay, so x over 100 is new value minus old value divided by old value. And I'm looking for new value. Okay, so here I have 14 over 100. New value is x minus 425 divided by 425.00. Okay, and I can find the answer here. So even you can make a formula. Okay, so this is so here so I multiple, so it is 4. Okay, so it is 425, this multiple 14, 100x minus 42500. Okay, so I have crazy. I have 100x. I'm not sure why it's not working. So 100x here is one side and 425 multiple 14. So I can do that. So it's 42500 plus 425 multiple 14. Okay. So what is the answer? So x is 425 plus 425 14 over 100. Okay, which is just like 14%. So I can say it is 425 plus 4250 this. Okay, so you can find the answer here. So it's 425 plus 425 multiple that, which is 485.5. $485.50. Okay, I can make a formula here. I can make a formula. New value, for example, I don't have new value. New value is old value plus old value multiple percent change. Percent change. So percent change divided by 100, that's a percent, is multiplied old value and it's added to old value. So if it's negative, something negative is added, so reduce I have. If it's positive, something positive is added, so increase I have. Okay, that's a good formula I can make. Okay, so now I can go to percent error. Error, as you just know, error is, for example, what I find minus what is the true value. Okay, so if positive, what I found is more than true value. If negative, what I found is less than true value. That's it. But I do not want to talk about error. I want to see percent error. So means the same as percent change. I want to compare error, which is here, with accepted value. This is accepted value. This is the true value. Accepted value. Accepted value comes from the lab manual, comes from the book, comes from your teacher. Many times we don't have it, the true value, but many times yes, so you can find out. Okay, so the accuracy of a measurement is specified by percent error sometime. Okay, so the percent error is the difference between what you got minus the accepted value, depending on the situation. So as I said, maybe you don't have it, but many times we have it because it's part of the book. Your teacher says that they believe you have to find this value. So if you don't, means something went wrong, so that will be error. Okay, so, and then you are comparing with the accepted value. That error is compared to see this error is what portion compared to accepted value, what portion of accepted value. Okay, so when I write one of them up, one of them down, it's like a fraction. Okay, so now I want to do this question. Working in the lab, a student measures the density of a piece of pure aluminum this. Remember, measures means it is what you got. The accepted value for the density of this is that. So this is maybe coming from the lab manual, it's coming from your teacher, you search for it, you know it. Okay, so we find density this, but the density must be the next one, the next value. What is the student's percent error? Okay, so remember, you always, for the percent change, you always compare with original. So here you compare with accepted value, because that's your unit, that's your main point that you want to compare. Okay, so that's your original thing that you want to compare. The accepted value is your main point that you want to reach to, not the measured value. So many times a student, they just ask me during the quiz and test, when we are doing quiz and test in person, they say, I forgot, in the denominator, should I use accepted value or measured value? What do you think? We are comparing with accepted value because that's important for us. Okay, so here the answer is, okay, here the answer is x over 100 equal 2.85 is what they find, minus 2.699 divided by 2.699. Okay, because both of them are gram per centimeter cube, I can just subtract. So gram per centimeter cube, gram per centimeter cube, and gram per centimeter cube. So now I can find it. So x over 100 equal 2.85 minus 2.699. So it is 0.151 divided by 2.699. Okay, so the answer is 15.1 divided by 2.699, which is 5.59. Okay, so x is 5.59 percent, which I can, or let me see, 5.594, and I can, okay, so because here I have, listen, here I have, so here I can have 3 significant digit, here I have 4 significant digit, so, oh no, here I'm doing subtraction there. Okay, so 699. Okay, so yeah, okay, so here I have 2 decimal place, here I have 3 decimal place, so I have to round to 2 decimal place. When I round to 2 decimal place, out of here, when I say 2 decimal place, means I have 2 significant digit, 2 significant digit. Okay, here 4 significant digit, 2 significant digits, so I need 2 significant digit. Okay, so remember, here I am, first I'm doing based on BEDMAS, first I am doing subtraction, and then I am doing division. So for subtraction, I round to the least decimal place, and then I have to ask myself, if I have 2 decimal place, remember, I don't round it in the middle of the calculation, no, I middle at the end. But when I have 2 decimal place, how many significant digits I have? Okay, 2 significant digit. I do not round. I do not use 0.1515. No, I do not forget 1. I just consider in my head. Okay, so if I consider 2 decimal place, then I have 2 significant digit, and down I have 4 significant digit, so I have to round to 2 significant digit. So I underline that, check that, I don't need that, so it is almost 5.6%. so that's percent error. I have to write a sentence. Many of you forget to write sentence, conclusion sentence in quiz and test. That's important when I'm doing word problems. Okay, so absolute value or not. So some books, they use absolute value and they just show it positive. Here we don't, because so it's not bad, because you can say, for example, you can say if you found something more than or less than, and you can have more knowledge about the experiment in the lab. Okay, so what you found was more than or less than. Okay, so the positive and negative gives you this information, and they are not bad. Okay, so the next one is percent yield. Okay, percent yield here. So let me see. Yeah, so the percent yield. Okay, so percent yield, so is percent yield is what you get when you are producing something. Okay, for example, I say I add this many kilogram of flour and this many sugar and this and this and this and this just oil, and then at the end I want to have, for example, out of this I should have, for example, a cake which is 2 kilogram, but then I don't get it. I have 1 kilogram and 900 gram. Okay, so I can find what is my percent yield in this product. Okay, so how much I got over how much I think I have to get. Okay, so the actual amount of product obtained from a chemical experiment is always less than. So we say often, but if you say it's 100%, means, for example, I want to have, so I believe I should have 2 kilogram cake, and then I have 2 kilogram cake. So either I forgot or I made mistake, because it's usually less than. Okay, so the more, the better. Here, when you have percent error, the less, the better the experiment, because the error should be less. Okay, for example, here 5.6% is a high percentage for percent error, but here I can have, if I have more, just a large number, that's good. If I say 90%, means I got 90% of what I believe I should get from this product. Okay, so the actual amount you get when you do a chemical experiment, when you produce something, is usually less than what you expect. Okay, so now you want to compare what you get really with what you expect to get. Remember, what you get is what you really have. What you expect to get, you don't have it. You just expect to have it. So we compare these two to find what is percent yield. So was percent yield 90%? That's not bad, because I have 90% what I believe I should have. When I do experiment, many things happen. I lose a part, something happens just maybe during the experiment, so for sure I don't have 100% what I expect. Okay, so I always have less than. Okay, so yeah, here. Okay, so here percent yield must be the higher, the better the experiment, but percent error, the lower, the better the experiment. Okay, so here percent yield. So a reaction of hydrogen and oxygen is expected to be 35 milliliter. That's expectation, means I don't have it, I just expect. But in reality, 4.5 milliliter are produced. Percent yield is for just producing something, for production. Okay, so I believe I should, for example, produce, for example, 2 kilogram, but then I produce 1.9 kilogram. Okay, so what is my percent yield? So I compare what I really got with what I expect. What I got is something that exists, which is actual yield. What I really expect, it doesn't exist. That's theoretical yield. It goes to the denominator. So this is my expectation. This is what I believe I should have. Sorry, that's what I believe I should have. So that's 35 milliliter. That's my expectation. But 34.5 is what I really got. Okay, so I have x over 100. So 34.5 milliliter. Both of them should be the same unit, 35 milliliter. And x is so 98.57. I underline that, I check that, so it is 98.6%. Okay, that's the percentage. Okay, so it's a very good percentage. So I expected to have 35 milliliter, I have 34.5. That's so good. Okay, so it's a high percent yield. That's a good production. Okay, so what I get goes up, what I believe, and if you know what's going on, then you don't ask, I don't remember which one goes up, which one goes down. Remember, what I get is compared with what I believe I have to get. So what I believe I have to get, what I expect, which I really don't have, it goes in the denominator. Okay, and you can just have a sentence, make sure to have the sentence. Okay, so you perform an experiment and 2.4 gram of NaCl are produced. Remember, this is what you have. The percent yield of your experiment is 94.5%. What is what you expect? Right now I am looking for expect. Okay, so 94.5 over 100 is 2.4 over x, and now I can find x. So x is 2.539. So here I do to two significant digits, so I underline that, so I don't need, so it is almost 2.5 gram. So I expect to have 2.5 gram, but when my percent yield is 94.5%, I got 2.49, sorry, to 2.4 gram. Okay, so I expect to have 2.5 gram, but no, I didn't. I have 2.4. Okay, so we can work with the formula to, for example, have different things. So here I stop for video 1. Okay, I want you to know, I want to emphasize here, for percent yield, if you know what's going on, then you don't forget the formula. For percent yield, the higher number, the better, because you are producing and you want to be close to what you expect. Which one goes up, which one goes down? Of course, if you know what's going on, you don't forget. Of course, what I get is compared with what I expect to get. So what I expect to get goes to the denominator. And what I got, up. How about percent error? Percent error is what I measure minus accepted value. That's the error, but it's compared with accepted value. Of course, I don't compare with my measured value, so I don't ask which one goes in the denominator. Denominator, of course, is my unit that is important for me. Accepted value, which comes from my teacher, comes from research, comes from the lab manual. Okay, so that's my accepted value, goes in the denominator. And here, when I talk about percent change, original value is what I have, and I want to know this change. What was this change compared to original value? Okay, so I use original value in the denominator. Okay, so now I stop here, and I continue in the next video to talk about percent concentration. Okay, percent concentration, different type of concentration. Okay, like percent W over W, percent V over V, and percent W over V. And then we move to part per million. And then at the end, we'll talk about molarity. We do several questions, and then just we are done. Okay, thank you for your time. Bye.